Hi, dear students. This video record is to demonstrate how a propeller, the model of a propeller, can be created in Inventor. Okay. Propeller, while making a Google search, you can find such pictures, such photographs. Well, for instance, this one is a marine propeller. It is just to assemble to the end of the main shaft of a yacht, boat, or ship, ocean liner. Okay, and engine rotates the shaft, and this propeller, well, push the sea molecules, water molecules, in the opposite direction of the motion of the ship, while the fluid particles are rotated in the opposite direction by the propeller. We have the thrust force, impulsive force, and that thrust force is used for moving the ship or boat ahead. In this photograph you see again we have a propeller, of course, in a different geometry, having a different characteristic. It is the propeller of a plane. Okay. Well, this is marine propeller. Okay, this one also a propeller. Okay, well, depending on the speed of the rotation, okay, and the kind of the fluid, whether it is very viscous fluid or very light fluid, whether it is air or liquid, whether it is just the propeller of a boat or propeller of an aircraft, then it is of course fixed by the designer how many wings in the design of the propeller. 3, 4. Here you see we have 3 panels, but there are 4 panels. Okay, blades, 3 blades, 4 blades. Here in this example 4 blades, and say the angle of the blade, inclination angle of the blade, also depends on the speed of rotation. While taking fluid mechanics or turbo machinery course, the course it is about rotating type bodies, okay, turbo machines, then you may learn the details on the design stage. But here in this video record, my purpose is to demonstrate after fixing the type and the size of such a propeller, how model is created. Okay, let's start. It is going to be a new creation. I selected unit system, part creation template, and then say create. Modeling starts from sketching stage, so clicked on start sketch button. Okay, and then select one of the coordinate planes. Well, here in this cat example demo, it is the propeller of a little boat, not the propeller of an ocean liner. Okay, the propeller of an ocean liner may be in the order of few meters to its diameter. If you want, I may find such a propeller. Okay, making one more Google search. Okay, not those, I think here. Yeah, yes, you see there is a shaft, and at the tip of the shaft we have the rotor propeller. Okay, well, make a Google search saying that propeller of an ocean liner. And then see the order of magnitude. You see there is a girl here at the arbor and see the propeller in size. Well, in this photograph you see the technicians just looking at the propeller, see the size of the propeller using the technicians as a measure on the order of magnitude. Well, in this example it is going to be a very little boat, okay, and it is propeller. So well, first have the core part of the propeller. It is a cylinder in shape. So we'll say that the diameter of the core is okay, then let's say 30 millimeters. 30. A little bit more, say that 50. Or say 56 centimeters. 50, let's say. Of course, it is while solving some equations, okay, design equations, it is fixed by the designer. Okay, and then finish the sketching stage and then apply extrusion process. Well, the propeller, say the blades of the propeller will be connected to their base to this central part of the rotor. Well, say that its length is 80 millimeters, or say 100 millimeters, let's say. And then, for being safe to site, save the file in the memory. This is the end of one of the stages. Okay. Okay, say that surname, ID, etc. And then say propeller. Okay, date of the classwork is today, June 2nd of June. Okay, and then, well, the order is not so important. First, have the first sketch and then the second sketch, or vice versa. One of the sketch is to be an helix in shape and 3D sketch. The other one 2D sketch. Okay, which one first? As I said, order is not so important. Okay, then take a sketch right over the surface and then have the first sketch. Okay, arbitrarily create a rectangle. In my mind, this strip corresponds to the edge of the propeller. The blade of the propeller. Well, to be able to input the dimensional constraints, have the characteristic point of this boundary, applying project geometry process. Now can indicate the center of it as the reference. Dimensional constraint. From here to the center, the distance is equal to 1.5 millimeters. Okay, from here to there, the total thickness at the root of the blade is 3 millimeters. Okay, from the center to this tip of the base of the blade is equal to well, for instance, say, okay, 150 millimeters or 60. Okay, not arbitrarily. As I said, all of such dimensions are determined by the designer solving the equations using the principles of fluid mechanics and the learning outcome of turbo machinery. Well, okay, here I'm going to trim this further extensions, no need to have. Okay, finish the sketch. Okay, one of the sketch is this one, and the other sketch 3D. Click on this listing arrow and select 3D sketch option. And then 3D sketch environment, actually after the sketching stage, after having the necessary sketch, inform you which process is applied or to be applied for creating the blade sweep. So sweep process requires a profile and a path. A path is a helical curve. Okay, so clicked on helical curve, and then the diameter of this core is 50. So into this box write 50 diameter. Okay. Gonna create the helix. From this list, selecting revolution and height option. Okay. How many turns the helix will wound over the surface of cylinder? Okay, write it into this box. And then the height of the curve. Okay, I'm going to fix those things. Number of turns is a quarter. Say that 0.25 is the number of turn. Okay, not full turn, quarter turn. Greater or smaller, this revolution turning amount is also determined by the designer. Okay, and then the height of the curve, say that it is 80. And then yes, this curve, use this the center of the base, and then the inclination, say not the inclination, the axis of the curve is just coinciding with the longitudinal axis of the cylinder. So indicated the center of the base, center of the tip. Okay, and then say apply. Close this dialog box and then finish the sketching stage. Yes, clicked on finish sketch button. You see over the cylindrical surface there is a curve. It is it has been wrapped over the surface. It is the path for the sweep process. Then the rest, apply sweep process. Clicked, and then yes, as the profile, indicate the strip, and then as the curve, indicate this curve. Clicked on this button and then have this blue underlining within the bottom edge of this display, and then can indicate the path. Yes, from the simulation I see that it is okay. And then clicked on OK button. That is it. Yes, have a look at. One of the blades of the the propeller is to its main part is now available. Okay, and then round the edges. Of course, the rounding value is also determined by the designer to prevent some undesirable vorticities while the propeller is rotating. Filleting process. Say that filleting radius is I don't know, say 14, and then round the sharp edges. Indicate this edge. Okay, or a little bit greater, say that 20, and the other edge as well. And then say OK. Yes. And then the rest, array copy. Clicked on this. This is the feature to create its copies. Okay. Clicked on rotation axis indication button, and the indicating the edge of this cylinder say that it is longitudinal axis is the distribution axis, okay, for the pattern. And then how many wings gonna have? 3 wings, 3 blades. Distribution, total distribution angle 360, and then say okay. Yes. Well, this end of the core is to be rounded in spherical shape. Okay. Hydrodynamically, it is going to be a better design. Clicked on rounding, and then rounding radius is 25. And then show this edge. And then say okay. Yes, I rounded the tip of the core. And then, well, within this central part, shaft hole is needed. Okay. Select this flat surface to create the shaft hole, or just apply the hole process. Yeah, well, I gave up. Instead of creating the hole primitively, applying extrusion process in cutting mode, I'm going to apply hole creation process. And then, well, the diameter of the hole, the diameter of the core is 50. Say that the wall thickness is 10 millimeters. 50 minus 20, it makes 30. Okay, so diameter is 30. It is truly? No, not truly. Select distance option, and then, well, the length of the hole. Well, the total length of the core is 100. Okay, length of the core, say that length of the hole is 70. And then indicate the surface. And then to say that the hole is coaxial, indicate the edge of the cylinder. The rest is achieved by the software, and then say okay. Yes, this is the shaft hole. Okay, this propeller is to be assembled to the segment of the shaft. Okay, this propeller is made of what? Made of brass. Yellow brass. Right click, yellow soft brass. Right click, assign. Okay. Here it is, the propeller. Well, although I said that array copy process and indicated the already created one with the recommended roundings, well, array copy process considered the initial form of the blade. So, well, you see, couldn't have the roundings at the edge of the created copies. So, well, unfortunately need to apply rounding process. Okay, one more time for rounding the edges of the created copies. This and the other edge for this, apply, and the other third say blade, round it is edge, round the other sharp edge, this edge. Yes. Okay, save the file one more time, and then the rest at the assembly environment. Assemble this propeller to the tip of the driving shaft. Yes. If you want, can create a shaft and then assemble this. But I think the rest is obvious. You already learned how a shaft is created, how the components are mated. Insertion type constraint, okay, is recommended. Okay, for assembling the propeller to the tip of the shaft, or just quickly create the shaft and then assemble the components. Assembly creation template. Okay, save the file without forgetting before applying the using the shaft creation tool. Save as well. Where okay, then in this folder, okay, say that propeller. Propeller and the shaft assembly. Okay, and then clicked on design tab and shaft creation tool, and then say that this is the shaft of the propeller, shaft of the little boat. Okay, then first locate it at the place arbitrarily with a click, and then this segment. I'm going to increase the length of this segment. Say the length of this segment is, say that 200 or 1000. Yes, it is extending to the output of the internal combustion engine. Okay, and this segment is the at the other side. This segment, it is to be mated to the hole of the propeller. Well, the diameter of the propeller, whole diameter of the propeller, I said 30. So this segment, diameter of this segment is to be in the same order. Yes, it is 30. And then say OK. Well, of course, there are some other features, okay, in the structure of this shaft, but assume that that is it. We had the shaft, the model of the shaft. Okay, located. And then our shaft is here. Where is the propeller? Where is the rotor? Okay, it's a non-standard component. So click on this listing arrow and select place option. And then in the dialog box, show the address. Since I didn't define this assembly work as project, actually I had to define it as project. So Inventor couldn't find the address, so asking me. Well, actually, since I skipped the project definition stage, that's why I need to show the address. And also applying the pack and go process, well, I'm going to be in difficulty, I know. But since there is no need to educate you on the pack and go process and project definition, just for saving the time, I skipped such stages. But assume that first I defined the work as a project, created the project folder, defined the work as a project, and then, well, in the project, as in the content of the project, well, creating such components and also the assembly. Assume. Yes, find the model of the propeller. Here it is. And then, yeah, in the assembly environment, first arbitrarily locate it with a click, press escape button, and then the rest, mating stage. Our shaft, well, forgot to assign the material. So take the shaft not into edit mode, but isolate it, left click, right click, and then say open. well, one more time, if it is not in part environment yet, couldn't find the model creation facilities as active, then indicate it one more time, and one more time right click and select open option, and then assign the material for this shaft. Clicked on material inputting button and say that stainless steel is the material of the shaft, and then clicked on save button. Close this part file. Yes, save it, and then turn back to assembly environment. The rest is joining, mating. Okay. I'm going to use this tool, say that rotational type joint. Okay. And then indicate this edge of this shaft hole, and then indicate the edge of this retaining ring groove, and then say that these are going to be assembled in this direction. No, it is opposite, so clicked on this one, flip flop. Now this direction is assembling direction is correct, and then say OK. Yes, you see at the tip of the shaft I have the rotor, and then fix the shaft. Right click and select grounded option, and then hold it, and you see can rotate it. I'm keeping the left button as pressed and moving the mouse following circular paths over the table or mouse pad. Yes, you can demonstrate that. Yeah, it is a rotor and it is to rotate. Of course, it is rotated by the shaft, so we tightly connect the propeller to the shaft, and shaft together with the propeller rotates. It is rotated by the engine. At the other end we have, imagine say gas turbine, some types of the bolts, or say internal combustion engine, diesel engine, or there may be an energy conversion system. Internal combustion engine runs an electricity generator, and generated electrical energy is used to run an electrical motor. Okay, imagine that we have an engine at this site. Okay, then. Yes, short demo. It is just specific. Today one of the students asked me, visiting my office, how a propeller, the model of a propeller can be created. For answering the question, not only for that student but for all of you, yes, I am recording this video film. My dear students, ending this record saying bye-bye. Allow you to see my face if you want, and then say that see you. Bye-bye.